taken to study the simulation of RAE aerofoil. The geometry of the RAE 5212 aerofoil is shown in here, and we can see it's a typical transonic aerofoil, and more specifically, it's a supercritical aerofoil. We can see the leading edge is blunt and thick, but the trailing edge has more camber. So this is a typical supercritical aerofoil. And this is a profile, and we can see this part, the top part is the upper surface, and the lower part is the lower surface. And what I'm going to do is to generate the profile, which can be imported into CCM. Okay, so I'm copying the profiles in here into Excel. Okay, so what we can do is just copy paste, and then we can see it's like this. Okay, so I need to delete the top part. Okay, and so what I will do is I first generate the up surface, the profile for the up surface, and then we do the profile of the lower surface. Okay, so this is up surface. The task now is we assign, this is x, y, y into b, and add a coordinate for c, which is 0. Okay, so Excel allows us to do this because we can see x and y is separated by a space. So we go to Data tab and choose Text columns, and we just next. So space, we choose space, disable tab, and you can see the data will be separated into 2 columns. Okay, and then finish, and you can see it's moved. So we can just delete column A, delete. Okay, and then we just need to add Z because Z is at 0. Okay, for now we have X, Y, Z. We just save it into CVS for the up surface, and we do the same thing for the lower surface. Okay, because I already done the export, you can do it yourself. Now we can start CCM. Okay, this is a simulation folder, and what we will do now is, as usual, go to geometry, 3D CAD profiles, 3D CAD models, new, right click new. Okay, we have the 3D CAD tab, and now what we're going to do is to import the aerofoil profiles. So we click 3D CAD model 1, right click, import, and choose 3D curves. And in this case, we first import the up surface, and there are a few options. We choose import as polyline, and we don't use the second option, polyline, because it will produce some further problems later. Okay, and now we can see the up surface, and let me adjust the view for you. Okay, and now we need to import the lower surface. Right click 3D CAD model, sketch, and import the curves. So now we do lower surface, open, and again use as spline. So now we have the entire aerofoil in this sketch. Okay, so now we do extrusion. Because we are going to do 2D simulation, it doesn't matter the distance, so we just use a default point 1 meter. Okay, so this is aerofoil in 3D. Okay, and now we want to generate the external flow field. And what we do now is, because it will be in the XY plane, we click XY plane, right click, create sketch, we need to adjust the view again. And for now, for the ease of creation of the sketch, we change the grid. So let's say spacing 1 meter and the fine graded 4, doesn't matter. Okay, so this is what we have. The chord of this airfoil is 1 meter. You remember in the coordinates. And usually the external flow field is about 10 tons of the flow field to eliminate the boundary effect. Okay, because we need to have the boundary further away from the aerofoil. Okay, so now what we do is create the external surface, and let's say 10 tons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it's here, and about here, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have it in here, okay? ESC, escape. Now we just plot the inlet, which is half circle, right? Okay. So this is the external flow field. We are going to do the flow simulation. Then we do OK. This is what we have. Again, we need to sketch and extrude this sketch. Extrude. And so we again use 0.1 meter. Remember here, body interaction, we should choose none. Otherwise, the airfoil will be merged by this one. It won't be showing then. Okay. So remember, we need to change body interaction to none, from merge to none. Then we click OK. So in here, we have two bodies. One is external flow field. The other is airfoil. Okay. So actually, we are going to simulate the flow field between the boundary and the airfoil. So it's in this middle part. What we need to do then is to do the double click both and then choose Boolean and subtract. So we're going to subtract these two flow field. So target should be body 2 and tool body is body 1. So the larger one is body 2. We just do the OK. So you will see the airfoil inside of the airfoil is removed. And let me adjust the view again. And we need to choose it into parallel. Okay, so this is simulation domain. And as usual, we need to name the surfaces. Then we can set up the boundary condition. So we right click. And let's right click both surfaces. So we need to press Ctrl and rename it. So aerofoil. Aerofoil. Okay. And here we have the inlet. So inlet contains 3 surfaces. So this is inlet. So now 3 surfaces selected. So it's called inlet. And also we have the outlet. Okay. If we go to here, name the surfaces, we have 3 surfaces, right? Inlet, outlet, and aerofoil. And also we need to name this side, right? So here, rename Z0 because it's smaller Z coordinate, and this one Z1. Okay. So now we have 5 surfaces. we can update the 3D CAD model and close it. So now we can see the geometries in here, and we can generate this player. This is simulation domain we created. So the next step is to generate grids on the surface. Remember, we're doing 2D simulation.